Okay, class. Right, now we come to the second part of the video. So, from the first part of the video of today's asynchronous class, okay, I introduced to you the equation, right? A matrix times with an eigenvector is equals to an eigenvalue multiplied with its eigenvector. Alright, basically in this chapter, as I said at the beginning of the first part of the video, okay, our aim is to find the eigenvalues and the eigenvector, right? Okay, actually this slide is going to show, is a derivation punya slide. Okay, it's going to show to you how we can find the eigenvalue first. Which one is the eigenvalue? X ke lambda? Lambda. Okay, eigenvalue. So basically kat sini kita ada ax minus with lambda x. Okay, we just bring the minus lambda to the right hand side dan kita ada sama dengan kosong, betul? Okay, and here when we factor x out, you will get a minus with lambda sepatutnya kan? Minus with lambda. And then, okay, lambda darab dengan 1 lah sepatutnya. Kan? So that when you multiply again, x times a, you dapat ax minus with lambda. Lambda darab dengan x. So 1 darab dengan x, you dapatlah lambda x. But remember, this is matrices operation. So dalam matrix, 1 ni sebenarnya equivalent to apa? Identity matrix. Remember? Identity matrix, which is, macam mana identity matrix? Kalau 2 darab 2 punya identity matrix, maknanya 1, 0, 0, 1 kan? What is so special with this identity matrix? Ni consider revision lah to all of you. Okay, identity matrix ni kalau kita darab dengan another matrix, we get back that another matrix. That's why saya kata identity matrix ni ibarat macam satu lah in algebra. So, here we are. Kita dapat a minus lambda times identity matrix. Times with identity matrix. Okay. So, from here, actually there are some derivation punya part. You can have a look on your own later how actually we come to this conclusion. Okay, kita tahu B does not have an inverse. Maksudnya determinant B tu sama dengan kosong, betul? Sebab B, to find the inverse is equals to 1 over determinant of B darab dengan Cij kan? The cofactors transpose. So, when the condition where the determinant B ni sama dengan kosong, that is when our matrix B does not have an inverse. Kenapa yang ni nak consider the case when B does not have inverse? That is the condition when the matrix X will be an eigenvector of A. Okay, because this is just a matter of derivation. I leave it to you to self-study. If you don't understand, you can get back to me. Okay, saya saja je nak buat lompong-lompong kecil sikit untuk you all ni, supaya adalah nanti reason untuk you get back to me and ask something. Okay, kalau tak semua faham, senyap je nanti kan. Alright, so I jump straight to this slide. Remember what I said just now? Okay, our aim is to find the eigenvalue and eigenvector. So first of all, kita akan cari eigenvalue dulu. Okay. So coming back from here, okay, yang ni kita ada ni tadi kan, a minus lambda times with I. Okay. What is so important here, determinant of B or determinant of a minus lambda I, because ni nampak kat sini, B is equals to a minus lambda I kan. Okay, what is important here, because this is when this is used for us to find the eigenvalue. The number lambda is an eigenvalue of matrix A if and only if A minus lambda I is singular. Singular ni apa maksud dia? Ni yang maksudnya B tadi tu. Okay, kita kan let B equals to A minus lambda I. Singular ni maksudnya dia tak ada inverse. B inverse does not exist. So if B inverse tak does not exist, maknanya okay, determinant dia sama dengan kosong. The determinant is equals to 0. So meaning the determinant of A minus lambda I is equals to 0. So that's why the condition dia datang kat sini. Okay. So then from here we can get the characteristic equation. Determinant A minus lambda I is equals to 0 involve lambda not x. What is this x? This x is eigenvector. Okay, so for each lambda, kita solve this, kita dapat lambda, dan daripada lambda tu nanti kita akan determine what is the eigenvector. It's okay kalau you macam benda lecturer ni cakap tak faham. Okay, relax semua. You will understand through example. So without wasting the time, now let's proceed straight away to the example here on how to find the eigenvalues. Ingat? Okay, so to find the to find the eigenvalue is our first learning outcome for today. Alright, so we have a matrix A here, very simple matrix, 2 times 2 matrix. Okay, you want to find the eigenvalue of matrix A. Okay, as I said tadi, okay, to find the to find the eigenvalue of matrix A, kita cari determinant of A minus lambda I equals to 0. Ni matrix A. So how to get a matrix A minus lambda I? Ni maksudnya matrix A kita adalah apa? 2 minus 12, 1 negative 5. Ini kita punya matrix A. How to get matrix lambda times I? Lambda times I. Okay, maknanya kat sini lambda is a constant times with I. What is I? I is a identity matrix which consists of, since A is 2 times 2 matrix, maknanya I ni adalah 2 darab 2 punya matrix. So you will get 1 0 0 1. So in this case maksudnya A lambda times I will give you lambda 0 0 lambda. Nampak? Okay, so maknanya kat sini this is going to be lambda 0 0 lambda. So this is matrix lambda times with I. So from here maksudnya you dapat matrix A minus lambda I is equals to 2 tolak lambda. Negative 12 tolak kosong. So you still have minus 12. 1 tolak kosong. 1. And then negative 5 minus with lambda. Alright. And then from here, maksudnya, when you say that you want to find the determinant of this, minus lambda I is equals to the determinant of this one. 2 minus lambda, negative 12. 1, negative 5 tolak lambda. Maknanya, macam mana nak cari lambda, determinant of this. Faham semua? Okay, we want to find the determinant of this. Okay, so saya sapu semua, saya tulis kat sini cantik-cantik. So maknanya for this one will equals to 0. Remember the punya condition ni, to find the eigenvalue we have to let A minus lambda I is equals to 0 kan. Alright, then from here, how to find the determinant? Kita darab silang, betul? So we're gonna have 2 minus lambda darab dengan negatif 5 tolak lambda. Kan, darab silang yang ni, lepas tu ni, macam ni kan. So minus negatif 1 darab dengan negatif 12 sama dengan kosong. So here you will get minus 5 darab dengan 2 negatif 10. Okay, minus 2 lambda plus 5 lambda plus lambda square. Okay, betul tak saya buat ni? Minus 10, minus 2 lambda, plus 5 lambda, plus lambda square, plus 12 equals to 0. So what you will have here is lambda square, negatif 2 lambda tambah 5 lambda, you akan dapat plus 3 lambda. 12 tolak 10, you will get plus 2 equals to 0. So see, you can factor or not this. It become an algebraic expression. So you can factor this, you will get lambda plus 2 lambda plus 1 equals to 0. There you go, you will get how many? Lambda, 2 lambda, where lambda equals to negative 2 and also negative 1. Okay. Okay, that is the solution, which is lambda equals to negative 2 and negative 1. Ni kat sini ada magic sikit. Kalau you tengok I slide ni, sebenarnya ada solution dekat slide ni. Okay, ada solution where is it the correct answer correct or not? Kalau you nampak lah. Kalau you punya own slide, you boleh nampak ni. Where the eigenvalue is equals to negative 1 and negative 2. Nampak tak ni? Okay, negative 1 and negative 2. Dia bertindak dengan saya punya tulisan ni. Tapi kalau tengok cara dia buat ni is slightly different from mine. Why? Because this one dia guna formula minus lambda I tolak A. Saya guna A minus lambda I. Actually sama je. And it has been proven. Jawapan kita sama. That's why kita letak modulus kat sini. Modulus ni sebenarnya determinant. Determinant maknanya the sign doesn't care. At the end, it will give you the same answer. Alright, so the answers are negative 2 and negative 1. Okay, before kita proceed untuk cari eigenvector, alright, you may try, kita try untuk cari yang ni pula, yang B pula, alright. Okay, let's try find B. Ni, nampak tak? Yang tadi saya kata tak clear tadi tu. Okay, yang B pula, maknanya ni adalah kita punya matrix A. So, lambda times with A, lambda times with identity matrix will be lambda, kosong, kosong, lambda kan. Very simple, betul? A minus lambda I, dia akan jadi apa? Dia akan jadi, kita nak cari dia punya determinant, maknanya dia akan jadi 1 tolak lambda, right? 2 tolak kosong, 2 tolak kosong, 4 tolak lambda. Right. Then this one will become 0. This is how we want to find the determinant kan. So cross multiply, darab silang macam kita buat tadi. 1 minus lambda, darab dengan 4 tolak lambda. Minus 4 equals to 0. So what you will get here, okay, buat je lah macam tadi. 1 darab dengan 4, 4. Tolak lambda, tolak 4 lambda, kan? Tolak lambda, tolak 4 lambda, tambah lambda square, tolak 4 sama dengan kosong. Alright, so we have here lambda square minus 4 lambda, minus lambda tolak 4 lambda, you will get minus 5 lambda. There you are. This time kita dapat 4 tolak dengan 4, then it will be 0. So you will have this only. Lambda square minus with 5 lambda equals to 0. So how many lambda will we get this time? You have to be careful when you want to factor it out. Kalau silap factor, dia akan dapat 1 je. But there are actually 2. We have lambda minus 5. Right? Kita factorkan dia. So you will get lambda equals to 0 and also 5. So there are 2 values of lambda as well. Lambda equals to 0 and lambda equals to 5. Right, so I hope everybody is clear now on the step how to find the eigenvalues of lambda. Right, so kat sini dia cakap compute the determinant. So semua orang boleh faham dah kot dengan step ni. Okay, start with lambda power of n with the highest power. Macam tadi, macam ni kan, kita dapat power of 2 lambda. So it indicates to us that there are 2 values of lambda. The order of the lambda tu. Okay, it's a polynomial in lambda of degree n. This will indicate to us we have n and eigenvalues of A. Macam tadi lambda kuasa 2, so kita ada 2 eigenvalues of matrix A. Okay, in the next video, we will discuss on how to find the eigenvector. For each eigenvalue tadi, kita ada 2. For example, in the previous example, each eigenvalue will give us 1 eigenvector. So, see me in the next video.